everyone, here's your first lesson as a flipped lesson while we are out of school. The next unit we are doing is, the next lesson we are doing is Notes 5.4. I'll try to keep it pretty basic because it's really not that hard. So last time we looked at how graphs got wider or narrower, so fat or skinny. But again, we use those words wider or narrower. Now we're going to look at the graphs move up, down, left, and right. Okay? So we talked about how our parent function is y equals x squared. That's how all graphs are made based on this graph right here. So what I'm going to have you guys do is go to, whether you have a graphing calculator, if you were able to get one, or if you're using Desmos. I will use Desmos because I think we're a little less familiar with that. Let's graph these equations and see what happens. Okay? So let's go to, erase these. I apologize. I was just making your video for the tutorial. All right, let's type in here x squared. So y equals x squared is our first one. Then our next one is y equals x squared plus 2. And then our next one is y equals x squared minus 6. All right, so remember, they're all based on that purple graph. And I'm going to scroll down here. I did say in my video that to find the vertex, you guys simply just click the point. Click the vertex, and it'll tell you the point. All right, so everything is based on this purple graph. So when I put in the blue graph, y equals x squared plus 2, what happened? Well, if you notice, the vertex went up 1, 2. When I put in the graph y equals x squared minus 6, compared to the purple graph, that graph went down 1, 2, 3, 4, 5, 6 units. Okay? So when we added it, the vertex went up. When we subtracted it, the vertex went down. So what we want to say here is y equals x squared plus 2 moves the parabola up 2. Y equals x squared minus 6 moves the parabola down 6. Okay. Now I know you don't have these notes in front of you, so just pay attention, follow along, because you'll have a chance to do a quote-unquote homework assignment next. So state the vertex of the function y equals x squared plus 2. Let's go to it. Y equals x squared plus 2 was my blue function, so the vertex, it tells me, is 0, 2. So this guy's vertex is 0, 2. The vertex of the black function here, let's see, it tells me it's 0, negative 6. Okay? And we know they're minimums because they are the lowest points on the graph. So what do we think the turning point of y equals x squared minus 100 is? If when I add 2, it went up 2. If I subtracted 6, it went down 6. My guess is that when I subtract 100, my vertex is going to go down 100. But cool thing is you have calculators, you can check it. So let's type that in. Y equals x squared minus 100. Oh, okay, that's going to be hard to see. Luckily on here, you just scroll all the way down. All I'm doing is just kind of scrolling. I'm clicking and dragging it. Oh, there's a vertex, 0, negative 100. Now I know it looks like it got wider, but you have to imagine, this is much more closer to like the top up here than x squared is. So parabolas do get wider as they go out. But the black is not wider than the purple one here. It just looks like it is because, again, they're in a U. So they, oops, let's look at it here. They're skinnier down near the U. And if you notice, as they go up to the top, they're getting fatter. So skinny as you get down to the point, and then fatter as you go out. All right, let's try another one. Ignore that drawing. Let's go to number 2. Let's look at the equations or the functions y equals x squared, y equals x plus 3 squared, and y equals x minus 1 squared. So graph all of them in your calculator. All right, let's get rid of these. So I still have y equals x squared. Now let's graph the functions y equals x plus 3 squared. Again, come down here, square it. And let's graph the function y equals x minus 1 squared. Now, again, they're based on the purple graph. So the purple is our starting point. When we typed in y plus 3 squared, we actually moved to the 1, 2, 3, left 3. When I typed in y minus 1 squared, we moved to the right 1. I know it's a little confusing because you think it would have gone the other way, but that's why we put it in our calculator. So how did they shift? Y equals x plus 3 squared moved left 3. Y equals x minus 1 squared moved right 1. Okay? We will look at ones, I think probably on the next page, where we'll see if they get wider. They might flip, they might move up and down. So we'll see. Oh, here's my bad drawings here. State the vertex. We have 2 more problems here. State the vertex of each of them. So the vertex of this one, of the blue one, is -3, 0. The vertex of this one is 1, 0. Remember, if you're using a graphing calculator, how to do that. You put the graphs in, you do max or min. In this case, they are minimums. Remember, you go left of it, you go right of it, and then you find the vertex. I'm only using this one because Desmos, because I think we're a little less familiar with it. So the next question said, what would the turning point of y equals x minus 9 squared be? Well, let's plug it in and see. X minus 9 squared. The vertex is 9, 0. Which makes sense. We would think that it would have gone right. I'm sorry, left because of the negative, but it actually goes right, 9 units. So this moved over from the vertex 9 units. You don't need to memorize these rules. We have calculators. You can just plug them in and see what happens. Okay. So describe how the graph of the parent function x squared shifts to become g of x equals x plus 5 squared minus 1. So let's graph them and see. Y equals x squared looks like this. The next one, y equals x plus 5 squared minus 1. Let's see what happens. Let's look at the graph. You look from vertex, turning point, to vertex to see what happens. So this graph, I'm going to just push this to the side for a little bit so we can see. Moved 1, 2, 3, 4, 5 units to the left. That's your left. And it went down 1, 2. So how do I get from turning point to turning point? I went left 1, 2, 3, 4, 5 units and down 2. So left 5 units, down 2 units. Okay, so count vertex to vertex and see what happens. Let's do one more, and then you have some on your homework. On your homework, make sure that you state if it got wider or narrower, if it moved left or right, if it went up or down, and which way if it opens a different way. I'll show you what that means because in a second, this one's going to do all of those different things. So let's do one more together. So we have y equals x squared. Now we're going to graph y equals, I got to pull up my keypad here, negative 1/2 in parentheses x minus 3 squared, oops, plus 7. Let's graph it. All right, let's look here. What happened to my graph? First thing, does it open up or down? So my original opens up, my new one opens down. So we want to say b of x, because that's this one, our new one, opens down. Is it wider or narrower? The red one is fatter or wider than the purple ones. We say it is wider. It moved. So from vertex to vertex, this one moved over 1, 2, 3 to the right and up 1, 2, 3, 4, 5, 6, 7. So we went 3 units right. Again, go from vertex to vertex, even if you want to go up first and then over. So I went up 1, 2, 3, 4, 5, 6, 7, over 1, 2, 3. So I went up 7 and right 3. And 7 units up. The only time that it's going to do something, meaning getting wider or not skinnier, wider or narrower, is if there's a number in front here, whether it be a fraction or just a number. But that's the only time when it actually gets wider or narrower. All right, on your homework, you are going to, you get, I can't remember how many questions I gave you. Let's see, let's go to classroom here. You guys have 1, 2, 3, 4, 5 questions. This one here is just old review, rational and irrational. This one here, there are 3 parts to the question. I want you to state the vertex of this function. State if it's a maximum or minimum. So does it open up or does it open down? And how did you know if it's a maximum or minimum? Is it the highest point on the graph or is it the lowest point on the graph? This one, I want you to describe how this x squared becomes this. Negative 3, x minus 2 squared plus 7. I'm going to tell you right now, it's going to get either narrower or wider. It's going to open down or up. It will move left and right, and it will move up and down. So I need you to state all 4 things. What does it do? Fat or narrow, up or down, left or right, and does it open up or down? This one, state your vertex. And this one, same thing. Make sure you state, does it move left and right, up or down? Does it get narrower or wider? And this one actually, they're both going to open up, so don't worry about that. So this question number 1 should have 3 answers to it, where question number, whatever one this is, should have 4 parts to it. I will be checking your homework. If you have any questions, feel free to email me and let me know. We can Google Meet, Google Hangout, however you want to ask your questions. Okay? Good luck, and I will talk to you all soon.